This video is how to use while loops in your code. Now, while loops are really handy because they allow you to repeat a section of your code as long as certain conditions are met. So it's similar to the until statement that you've been working with for your linear coding, but it's going to allow us a lot more flexibility when we start to have more complicated scenarios. So what we're going to do is we're going to talk about the structure of the while loop. We're going to talk about essentially what it does, and then we're going to do some interpretations, talk about Boolean logic, yes or no, true or false, interpret some code, and then maybe practice a little bit to kind of see where we are there. So what I'm going to do to just model how this works is I'm going to drag my while statement in. Now, as you guys get more comfortable with this, you're going to be able to just type this out. But just to help you out in the beginning, just to see how the structure works, just to make sure that you have the right parentheses and the semicolons and all that stuff, we're going to pull it from our function library. So if you notice, it's nested under control structures as long as you're in the right natural language programming. And it is under your control structure. So we see our while statement is right here. So I'm going to grab that and I'm just going to toss it right in the middle of my task main. So notice how we still have our task main brackets right there. We're going to put it right in the middle. Otherwise, it's not going to show our work. So while loops essentially have three pieces that we're going to focus on. Obviously, we have the while statement. It's not going to work unless we have that while statement there telling the program that we want it to loop for certain conditions. We have the body, which is whatever you want your code to do. So if you want your LED to blink, if you want your motors to run, whatever that might be. And probably the most important part of the while loop is that condition. So how while loops work is so long as your condition is true, your program will complete the body code. So let's do a quick example of that, kind of how to type this out, and then we'll do some interpretations and talk about why this stuff actually works. So I have my task description up here. While a bump switch is not pressed, have the motor run at full speed clockwise. If not, have the motor stop. So I'm going to chunk that up into some pseudocode. So notice how we have the while kind of in our task description to start off with. So I'm going to say, okay, my kind of statement, my initial condition is while a bump switch is not pressed, and that's going to be really important for us, and while that condition is being met, we want the motor to run full speed clockwise. So we're going to say motor run, maybe let's say right motor, just to be specific. Run at full speed clockwise. And if that is not the case, we want it to kick us out of the while loop and say, if not, stop the motor. Okay, so we have our kind of pseudocode designed up there. So how our body works is just like you've been doing with your linear code. We want our right motor to run at full speed. So I'm going to say start motor. And I'm going to focus on my right motor. Full speed is 127, and that's positive, making that clockwise. And then I'm going to put my little semicolon there. Now notice, when you're doing your regular linear coding, we still have that semicolon there. Your while loop does not. So by the condition, when we drag that in, it does not have a semicolon, so we're going to leave that like right there. So we've got our start motor. So let's go into our condition. And so for a bump switch, that is a sensor value. So we're trying to pull a sensor value so that when we have an input, we get a change in the output. So I'm going to type in, man, I can't type, sensor value. Yikes. And I am going to focus on the sensor that I want to deal with. In this case is the bump switch. So I'm going to put in square brackets. I'm going to say, I name mine bump switch, very clever. And then I'm going to type equals, and then the value that I want to come out. So when the bump switch is not pressed, it gives me a value of 0. So I'm going to toss it in right there. So what this is essentially saying is my while loop is going to look for the sensor value of my bump switch, and as long as the value that it picks up is 0, which means not pressed, it's going to complete the chunk of code inside of that while loop. And then we want to figure out what happens if that is not the case. So if it's not the case, I'm going to say stop motor, right motor, and then toss my semicolon in there. Notice how everything is still within that task main, so it actually runs. So essentially what we are doing is, as long as our bump switch is not pressed or giving us a value of 0, it's going to start that motor. And so what your program will do is it will read this and say, okay, is this 0? Yep, it's true. I'm going to do everything in the while loop. It's going to go back and check, is this 0? Yep, I'm going to do everything in the while loop. Is it 0? Yep, I'm going to do everything in the while loop. If you were to touch that bump switch, if you were to change that to a 1, your program will kick you out of the while loop. It's going to stop and your program ends. So it doesn't go back and do the whole thing. Once you are kicked out of your while loop, you are done. So let's do a quick little interpretation, and then we'll talk about why this works. We'll talk about some other ways that we can use this. So for our while loop, here is an example of some other things with our potentiometer that we could essentially do. So when I look at this, I see my while loop, and I'm looking at the sensor value. So this is telling me as long as my potentiometer is less than 2000, so if we have rotated it less than that, it's just going to have my LED blink on and off. And then your program will go back up. It'll say, okay, is it less than 2000? If it is true, it's going to keep going on and off. Is it true? Yep, on and off. Once you rotate your potentiometer equal to or greater than 2000, it's going to kick us out of the while loop, and it's going to start our motor for 6 seconds. So again, that will repeat over and over and over and over so long as your condition is being met. And all of that is based on Boolean logic. When you're dealing with a program, really what we're whittling it down to is your decisions are always based on a question, and the answer is either yes or no, or it's true or false. That is it. So everything that you create based on the motors, based on the sensors, is based on yes or no, true or false. And we call that Boolean statement. And there are a lot of different Boolean statements that we can use, especially within the while loop, to get things that we want out of the code. So the one that we already talked about is our sensor value. So we're able to use the inputs, in this case is the ultrasonic sensor. And we're saying that if there is an object that is farther than 45, typically inches or centimeters, depending on what you set, if that is true, it's going to go through your code. If that is false, it is not going to go through your while loop, and it's going to boot you out. Now, for Boolean logic, sometimes we have things that are always true or always false. So we have this condition of 1 equals 1. So then your program will say, is 1 equal to 1? That is always true. Always, always, always true in our code. So this is kind of how we design what we call a forever loop, because 1 is always equal to 1. So if you have a code that you want to just repeat over and over and over and over again without any other conditions in there, we can plop in a condition that says 1 equals 1. So if we go back to our code, let me jump back there real quick. Instead of while sensor value bump switch equals 0, I could say while 1 equals 1, start motor, which means it's going to say, is 1 equal to 1? Yep, start the motor. Is 1 equal to 1? Yep, start the motor. So if there is some code that you want to repeat over and over and over, use something that is always true, like 1 equals 1. Another thing that works is true or false, but we like to use 1 equals 1. But the fact is we have a lot of different things that we can use. So with a potentiometer, with your ultrasonic sensor, we can have things that are equal to, greater than, less than, not equal to. So notice all of these symbols that represent numerical kind of comparisons. So we dealt with equals. So if you put 1 equal sign, it is not going to work. So kind of keep that in mind. So when you say is equal to, we want to double up. Is not equal to, that one is kind of rare to use, because if you're dealing with not equal to, then you can just use equal to and do the other thing. But whatever. Exclamation point, equal sign. Is less than. classic math description, less than or equal to, greater than, and greater than or equal to. So you can use these however you want to get true or false values from your Boolean code. So again, with our forever loops, we could say while equals 1, and then we have our code happen inside of there. Or if you want to say just true, true is always true, just like 1 is always equal to 1. So both of those will work out. Both of those will get you exactly what you need to do. So let's do one more kind of an interpretation, and then we'll do a quick little practice one. So we have this code. And what I want you to do is go ahead and pause this video real quick. Take a little bit of time, check it out. Maybe turn to your partner, talk about what is that going to do if we were to run that. Play this video, and let's see if you are correct. So pause it now. Okay, I'm assuming you paused it. If you didn't, then you're a filthy liar. But anyway, we have our while loop up here, and that is a forever loop. So while 1 is equal to 1, we're going to run everything inside of that while loop. And notice how we have kind of a nested while loop as well. So this code is just going to go on forever and ever and ever and ever. But we want it to be a version of our sensor value. Instead of kicking us out and then stopping for good, the purpose of that forever loop is to repeat as long as we need it to. So it's saying while your sonar sensor is less than or equal to 50, so we're talking about our ultrasonic sensor, and we're detecting objects that are less than or equal to 50, let's say inches, it's going to start our motor. So as long as we have something close to that ultrasonic sensor, we're going to run our motor at half speed counterclockwise. And so our program will say, is it less than 50? That is true. Keep the motor rolling. Is it less than 50? That is true. Keep the motor rolling. As soon as we have an object that is outside of that bound, so greater than 50, it's going to kick us out of our loop and it's going to stop our motor. But what's really nice is as soon as an object goes within 50, it's going to start right up again because we have that nested within a while loop right there, which is really good stuff. So we have a lot more flexibility. They're very similar to until statements, but until will only let you go to the end of the code. For this, we are able to loop over and over and over as many times as we want. So what I would like you to do is I'm going to change this up. I'm going to delete all this stuff in here, and you have a quick task to show your teacher when you get to this point. So let's say your task description. So let's say while the quad encoder has completed less than 1 revolution, yikes, turn an LED on. There we go. So pause this video. Go ahead and type this out and show it to your instructor. Hopefully this video helped you out with our while loops. Go ahead and get a little bit of practice with that stuff so we can start to do some more nonlinear coding.